I'm Oscar Pizarro. I'm a research fellow at the Australian Centre for Field Robotics at the University of Sydney. Preparing to be able to do effective surveys and bringing all these systems to work together requires a fair bit of work and has to be accounted for. So we're spending 2 or 3 or even maybe 4 days just making sure that everything's lining up properly before we actually collect data that's useful. Typically in the movies, you never see that. Part of it maybe it's science fiction, or they just show up and the robots go and all that. Arguably, it can be brought to that level, but in general, for the type of work we do, people still do a lot of this semi-manually, and it's not a completely automatic process. In many cases, these calibrations rely on having some overlapping ways of assessing the same type of motion or observation. So, for instance, if we have a series of pictures of the seafloor as we turn around, we can figure out how the vehicle was changing its orientation, its heading, using the images, and compare that to what the compass was saying. And from that, we can back out a correction or a compensation for what the compass is doing.
My name is Richard Camilli, and I'm with Woods Hole Oceanographic. I'm a scientist. The problem that we have is that there are no road signs and highway lanes for the robots to drive down underwater, and we don't have the benefit of GPS underwater. So the only way that we can get our position is through inertial navigation systems and Doppler systems. The thing that happens is that if our compass calibration is off, if it's 15 degrees off, we'll be going 15 degrees in the wrong direction. And if you do the trig, if you go a few kilometers, you can be off by a long, long ways. And that creates a problem here, not only because you don't go where you intend, but you may actually go into a dangerous area and become entrapped in a coral or something like that. Well, there's two kinds of calibration for these compasses. One is to calculate the variance, so that's the change in the Earth's actual magnetic field. Then there's also the vehicles themselves have ferrous metal in them, and that creates distortions that they can't get away from. So you have to calibrate out those distortions, and you do that by taking heading measurements at different headings and doing reciprocal headings and looking to see how the magnetic heading has distorted. When you know that you've spun 180 degrees, but it tells you you've only spun, let's say, 170 degrees, you know that there's a 10-degree error there, and you can compensate for that. We're taking heading measurements at known locations and actually using another compass to tell us, okay, we should be measuring true or 0 degrees, so north, and we cross-reference that with what the glider was telling us, and then south, east and west, so the cardinal directions, and then a few other in between. I was moving the vehicle around up on the island there. Agilus was back in the boat working on the laptop computer, and the computer was talking with the glider via radio link, and that's why we had that antenna there.